S block elements. It has two groups that we are going to study today. First is group 1. The other is group 2. Group 1 is known as alkali metals. These are known as alkaline earth metals. Metals, why? Because they have metals. Whenever you see the metals, it means that they have a tendency to lose electron. Alkaline and alkaline, or the word alkali, it means that when I put these metals on base in water, they form, or they increase the concentration of, or rather I should say in water they form base. A good example will be if you have sodium plus H2O, then you are going to get NaOH, and hydrogen gas will be liberated, okay. So you are going to get bases when you react this with water. That is why this is alkali metals. Similarly, alkaline earth metals. Now this word earth, because most of the elements of this group, they are found in Earth's crust. So this is the general introduction. Now, moving to the group 1, that is alkali metals. Moving to alkali metals. Now, in alkali metals, we know that alkali metals, we have lithium. What are the elements in alkali metal, guys? Tell me. What are the elements?
Lithium.
Lithium.
Sodium.
Potassium.
Rubidium.
Then rubidium. Then
CS.
okay, cesium and francium. CS, and then you have francium. Okay. Now in this francium, it is radioactive. This radioactive. Now it is radioactive, and the next thing is that all of these metals are silvery solid. They look like silver and they are solid. Okay, they are silvery solid. If I talk about the general electronic configuration, then that will be NS1. It means that their outermost electronic configuration is what it is NS1, or rather I should say it will be any noble gas, and then NS1. So lithium, it is in which period? Lithium, it is in second period. This is in third period. This is in fourth period. So for lithium, it will be the noble gas, that is helium, and then 2s1, right? Then for sodium, similarly 3s1, 4s1, 5s1, 6s1. And by the general electronic configuration, I can see the valence electron is how much, guys? Tell me. The valence electron. How much is the valence electron? How many electrons are there in the valence shell?
1.
Yeah, very good. 1. Why are others not answering? Have you not studied the periodic properties like at all? I know, like for the most of the students, I started with the second term syllabus, but I hope you guys have learned something in the periodic properties, right?
Yes.
Ali, I'm asking for those who are not answering anything. Yes, Khalil, Minashi, Mazia, Razan. Back, acha, okay, that's why you're not answering. Okay, fine, got it.
Assalamu alaikum, sir. How are you, sir?
Walaikum assalam. Walaikum assalam. Yes, Sayyid Muhammad. चाहिए आपने पे सलाम करना था. Okay, fine. So valence electron is equal to 1, and that is why I can say general oxidation state, the common oxidation state, the only oxidation state that you are going to get, it is equal to +1. Oxidation state of alkali metals is going to be +1. Now moving on to the atomic radii and the ionic radii. Moving to atomic radii and ionic radii. So atomic radii and ionic radii. So these will, from top to bottom, the AR and IR, atomic radii and ionic radii, increases due to new shells. Because if I go from second period to third period, that means I am adding the third shell. So this is the simple point regarding atomic radii and ionic radii. Next is ionization enthalpy. Ionization enthalpy means the amount of energy that is required to take the outermost electron from a neutral isolated gaseous atom. From a neutral isolated gaseous atom, the M will get any metal and you will take out an electron. It will become M positive plus electron. So here M is what? M is what? M is the group 1 element: lithium, sodium, potassium, rubidium, cesium, and not francium, because francium is radioactive. We don't talk about the chemical properties and physical properties of radioactive substances. So ionization enthalpy, it will depend on how far the electron is from the metal. So as the size is increasing, the ease of removing electron also increases. So it is easier to remove electron if the size is larger, and hence the order will be, we can talk about the ionization enthalpy as the ionization enthalpy decreases as we go down the group. As we go down the group. And that is why I can say that lithium has the highest ionization enthalpies, followed by sodium, followed by potassium, then rubidium, and then cesium. This is the trend for ionization enthalpy. Trend for atomic radius was lithium has the smallest size, followed by sodium, followed by potassium, then we have rubidium, and then we have cesium. Okay. Next is more important, that is hydration enthalpy. That is hydration enthalpy, and we have just learned about hydration enthalpy in the chapter that is thermodynamics. That is thermodynamics. That is hydration enthalpy. So hydration enthalpy means when we have any gaseous atom and when they are interacting with the water molecule, that interaction leads to hydration enthalpy. So first thing is for hydration enthalpy, you need a gaseous atom, any metal, that is gaseous ion, a gaseous ion. This will interacts with H2O, right? It will interact with H2O. So what I will see about hydration enthalpy is two things. I will talk about lithium positive, okay, and I will talk about cesium positive. Lithium positive and cesium positive. Now, I'm asking simple question, and I am asking a very simple question. Please listen carefully and answer me. This positive charge is where? Where is this positive charge? In the nucleus or outside the nucleus? If I'm talking about the positive charge in a particular metal, where is it? In the nucleus or outside the nucleus? What happened, guys? No idea about this positive charge? Okay. Yes, Khalil, Maimuna, Mehreen, Minashi, Razan. Okay, fine. Answer me something very more basic. That is, what are the subatomic particles? Like inside an atom, what are the things that I can see? Not see in the sense, but what are the things that are present inside an atom?
So electrons, protons, neutrons.
Electrons, protons, and neutrons. So these two things are in nucleus, right?
Yes, sir.
Electron is away from nucleus, right? It has a cloud, it is around nucleus. Okay, it is around nucleus. And nucleus is very small. Like it's very small. It is an analogy that is very appropriate is that if you have a football ground and at the center of the football ground, you keep a tennis ball or a golf ball. So that golf ball represents the nucleus and the atom is the football ground, right? The atom is the football ground. So nucleus is that small. Nucleus is going to be that small. So it is very small. Now, whatever positive charge you are having, it is due to the imbalance in the numbers of electrons and protons. Because if I see lithium, it has 3 protons and it has 3 electrons. So there are 3 positive charge and 3 negative charge, and hence this atom lithium, it is neutral. But if I take an electron away from the lithium, then the proton is not going to change. The proton is 3 positive only, but we have changed the number of electrons. Now it is 2 electrons. And now there is an imbalance in the number of charges. There is an imbalance in the number of charges, and hence we can see that there is 1 extra positive charge. That is why this lithium is getting a positive charge. All of you get this? Yes or no?
Yes, sir.
So
Yes,
we are
please.
not adding anything. We are not adding anything. We are removing something, and the charge is getting developed. The charge is getting developed. So the charge is where inside in nucleus or outside the nucleus. This charge, positive charge,
In the
Inside.
nucleus.
in nucleus, right? Very good. In nucleus. Now this is very important. This is very important. It is in the nucleus. It is in the nucleus. Now you tell me, guys. I have a positive charge, and I can show that this is lithium, right? Because there is a positive charge and there is a small atom, and only 1 shell now. Because if you have lithium positive, that means only 2 electron, and hence it will be 1s2. So lithium is going to be very small. But instead, when I draw the cesium atom, so I can draw and I can represent it like this, and then I will draw a positive charge somewhere here, right? A simple small positive charge. Okay, a simple small positive charge. Now this is positive, and if I look at water molecule, now water molecule has both the ends. Water has a positive end and water also has a negative end. Because water has lone pair electrons, these are negatively charged, right? These are negatively charged, and there is electron density higher when you see the oxygen atom, because it is more electronegative. It pulls the electron from the bond, and it is delta negative. And the hydrogens, these are delta positive. Right? And I can see it is 2 delta negative 2 times, because here we have delta positive and here will be having 1 delta negative due to this hydrogen, and there will be another delta negative due to this hydrogen. That is why the oxygen will be 2 delta negatives. Is everyone fine with this? Yes or no? Tell me. These 3 things.
Yes, sir.
These 3 things.
Yes,
So we have lithium positive and we have cesium positive, and we want to look how are these 2 things interacting with water molecule. So I can obviously say now, since water can approach till here, right? Very near. Now water is very near to the positive charge, right? If it is interacting with lithium, yes or no? Correct?
Yes, sir.
Yes, sir.
Now, when water wants to interact with the cesium ion, it is around, it will be only around the atom, right? It cannot go inside the atom to interact with that positive charge. And hence I can say that the distance between the oxygen, that is delta negative, and the positive, that is inside the proton of cesium, it is like the distance is very large, and hence the interaction of lithium is going to be very strong. It's going to be very strong if I compare that with the cesium atom. Yes or no, guys? Correct?
Yes, sir.
Yes.
Right. So for hydration enthalpy, we can easily see a trend. And the first point that we will write is it is inversely proportional to hydration enthalpy. It is inversely proportional to size. If size is small, the hydration enthalpy is going to be very high. And the order will be that lithium positive will have the highest hydration enthalpy, followed by sodium positive, followed by potassium, rubidium, and cesium positive. Yes or no? No problem, guys. Yes or no? Any problem till here?
No,
No,
sir.
No problem, right? Okay. Now we will look at the hydrated ion and the size of the hydrated ion. See, because if I look at lithium positive, okay, so I'm making again. Okay, Unib Hassan, I don't think he's our student. So we have a small positive charge and there is water molecules around it. Okay, so rather than making water molecules like this, I'll be making water molecules like this, okay? So because this is positive charge and there is no interference, any interference is not present, right? And the water molecule is directly interacting and it is very closely interacting with the positive charge. Many water molecules are going to come and they are going to surround the lithium positive ion. But if I compare the same thing with the cesium ion, then I can obviously say that even if the cesium ion is larger, there will be very less water molecule that will be around. There will be very less water molecules that will be around the cesium ion. Yes or no, guys?
Yes, sir.
Right? Now, and so I can say if I look at the size, if I compare the size of these two things, size of the hydrated ion, that means the ion and the water molecules that have surrounded it, that is known as the hydrated ion. What is hydrated ion? The ion, the metallic ion, and the water that is surrounding the metallic ion, that is the hydrated ion. And in that, I can say that the size of the hydrated ion in which the metal is small is going to be very large because it is surrounded by many more water molecules if I compare that to a bigger or larger metallic ion, right? So when I compare the size of hydrated ions, this is very important, guys. This is something new that has been not taught in the periodic properties. Okay, this is not in the periodic properties. So please remember, size of hydrated ions, size of hydrated ions. Now, in size of hydrated ions, the lithium positive is going to be largest, followed by what is next? Lithium, sodium, potassium, rubidium, and then you will have at last cesium. Now, if this is the size of the hydrated ions and in water, these ions may move, right? These ions can move. There will be some mobility that is allowed for these ions. And since lithium positive is what? It is very large in size. It is the largest in size. The mobility of lithium positive will be drastically very low. So this is the size of hydrated ion. The next is ionic mobility. In water, how fast can lithium positive, sodium positive, and the group 1 metal ions, they can move inside water to conduct electricity? So when we will be talking about electricity in the next class, that is 12th class electrochemistry, then we will be coming back to this point about the ionic mobility of different ions in water. So the ionic mobility will be having this trend that lithium positive will be slowest because it is having a very large size inside water, not outside water. Outside water it is smallest, inside water it is largest. Lithium positive, followed by sodium positive, followed by potassium positive. Then we'll have rubidium positive, that is, and then the cesium positive will be fastest. Right? This okay. Done. Tell me, any doubt till here?
No, sir.
No doubt, right? Okay, fine. So these are the points. I can say that these are the properties or the physical properties of the group 1 elements, physical properties of group 1 elements.
Sir, so if the size is of the ion is bigger, then the mobility will be more.
Like pure ion, not the hydrated ion.
Yeah.
In water. So when we are talking in water, if you want to have a direct relationship, so in water you will be looking at the size of hydrated ions in water. But in general, you can say that it is following the same trend. If I look at the pure ion, if the size is large, the mobility will be high in water. Okay.
Okay, sir.
Okay. Next is the chemical properties, right? Chemical properties. So these are the important points in your physical properties. Next is chemical property. Okay. Now, first thing we should discuss, why are these like, what is the reactivity? You know, what is the reactivity of these elements? What is the reactivity of these elements? So when I talk about anything that is reactive, and if I want to talk about the reactivity of anything, that means I am talking about the ability of do reactions, ability of doing reactions. And whenever you are doing reaction with other elements, with other substances, right? With other substances. Now, when I'm talking about the reactivity of any element or reactivity of anything, then I am talking about the, when you have, okay, whenever the reaction happens, and for example, sodium can form NaCl. So what changes in sodium and what changes in chlorine? The number of protons or the number of neutrons or the number of electrons, guys? What changes if sodium goes from sodium to sodium chloride? Anything changes or nothing changes? Something changes, yes or no? Sodium and sodium chloride. So the sodium that is present in metallic state and the sodium chloride, the sodium that is present in sodium chloride, is anything different between those two sodiums, or both of them are same?
So sodium ion is there in NaCl.
Sodium ion. So what is the difference between sodium and sodium ion?
Sodium ion is unstable, sir.
No. Like in the, if I talk about its constituents, so an atom, it is made by protons, electrons, and neutrons, right?
It will be positively charged.
No, fine. So I am again talking about the constituents. So in constituents, you will have protons, electrons, and neutrons. So what is something that is same in sodium and sodium positive, and what is different? What is happening? Are the number of protons changing, a number of electrons changing, or number of electrons changing? So whenever there is a reaction, there is a change in electrons, yes or no? So what happens? There will be some flow of electrons. All reaction, you can boil it down to flow of electrons. Now, when there will be flow, there will be some element, on an atom or a substance that is losing electron, or there will be something that is gaining electron, right? There will be loss by someone and there will be a gain by some, right? Whether you're talking about species or elements or any other ions. Now, when I talk about losing or gaining, so first of all, we have seen that they are going to lose electron because there is only one electron, and if they lose this one electron in NS1, they are going to achieve the nearest noble gas configuration. They are going to achieve the nearest noble gas configuration. So we have mentioned that they are going to lose electron. Now, how easy is this loss of electron? How easy can they lose this electron? So we will talk about that. First of all, how many electron do they lose? How many electron do they have to lose in order to react? So they have to lose only one electron. They have to lose only one electron, and they, after losing one electron, they are directly going to the noble gas configuration. So we can write the alkali metals have high reactivity due to, number one, low value of delta Hi, ionization enthalpy. Okay, next is large size. Now you will be wondering, how large size, sir? Large size kaise? If you look at a period, and if you go from left to right in a period, then the size decreases. That means if I compare all the elements in a period, then we have the group 1 that is coming first, and they are going to have the largest size, because as we go from left to right, the size decreases. So they have comparatively large size. And these are the two main reasons for the high reactivity of the group 1 alkali metals. Okay, and this is the most prominent reason, that is the low value of ionization enthalpy. Next is, we will look at some reactions. When I look at reaction, one of the prominent reaction is, how does it react with air? So reaction with air. Now in air we have most prominently oxygen is present. So how does these metal they react with the oxygen? So we have lithium, it reacts with oxygen, and it is the only element which forms oxides. So you'll form Li2O. It is going to form oxide. Next element, that is sodium, it reacts with oxygen and it forms peroxide. That means Na2O2. Na2O2. Next, you have the rest of the elements of the group, the subsequent element of the group, they react with oxygen and they form superoxide. So as you can see, what is happening, you have for each metal, you have for each oxygen atom, you have initially two metals. Why? Because oxygen is 2p, second period. Lithium is also second period. So oxygen can handle two lithium and it can be the central metal around the lithium ion. Okay, around the lithium ion. Next, followed by, if you go towards sodium, sodium is a bit bigger. So it requires one oxygen atom can only handle one sodium. It only handles one sodium. I have not written the superoxide. So superoxides are MO2. Now, when I go further down, that is potassium, rubidium, cesium. In that case, is what happens? One of the oxygen, or rather one metal can be only handled by two oxygen atoms. It can be handled by two oxygen atoms. That is why it forms superoxide. The size is the matter here. Okay, size is the matter. So if you have size that is a small, that means one oxygen can handle two lithiums. Then you have oxygen, which can handle only one sodium. So you have Na2O2. Then furthermore, two oxygens are required to handle each metal. Next is, so there is one question that you have to calculate the oxidation state of sodium in O2. Oxidation state of sodium in O2. So no matter what is the case. So can you guys calculate the oxidation state of sodium in Na2O2? Try to calculate. For sodium, what will be the oxidation state of sodium in Na2O2? Listen, no matter what oxidation state of group 1 element, it is always going to be +1. Okay, it is not going to be anything else. It will be only +1. So sodium, whether it is Na2O2, the oxidation state of oxygen is going to change from, it will be -2 here. It will be -2 here. And in this case, it will be -1. And in this case, it will be -half. Okay, the oxidation state of oxygen changes from oxide to peroxide to superoxide, but the oxidation state of metal, it is not going to change. Metal is not going to change. Okay, next is reaction with water. Reaction with water. So obviously we know that whenever we add water to the metal, it is going to give me hydroxide, that is a base. Second is reaction with water. So you have metal plus H2O is going to give you MOH, metallic hydroxide, plus H2 plus H2. Okay. So what is metal? Metal is any alkali metal. So metal will be lithium, sodium, potassium, and so on. Okay. Simple reaction with water. Third is, you can write reaction with H2. Dihydrogen. Reaction with dihydrogen. So it will react with H2 and it is going to form. So reaction with H2O forms hydroxide. It forms hydrides. It forms hydride. at high temperature, but at high temperature. So you'll give some heat, and then you are going to form metallic hydrate with the formula MH. You can balance these reactions like this. And water also, I think it will be 2. Yeah, right. Next is a reaction with halogen. What it will form? It will be forming halides. Forms halides. It is going to form halides. You have M plus X2, and it is going to give you MX. Okay, just a point here. These are ionic in nature. These are ionic in nature, but anything which is ionic in nature, it will have some more or less. There will be some more or less covalent character. Now, if I want to talk about the covalent character in the halides of group 1 element. So what is a covalent? What is a covalent compound? In covalent compound, we have, this is the nucleus and this is another nucleus, and there is electron density in between here. Yes or no? Correct? This is how bonds form, no? You will have electrons between 2 nucleus, right, guys?
Yes, sir.
Yes. So this is how we should picture covalent. This is covalent. And if I talk about ionic, then there is positive and there is negative charge here, right? There is negative charge here. So there is only electrostatic. There is nothing between these two charges. There is only electrostatic force of attraction is there. Hai na? There is force of attraction, but there is like in not any particle is not present between these two atoms. Hai na? So there is one atom which is positively charged, the other atom is negatively charged. Again, in real life, you will not see anything that is like this now, a positive sign. So we represent positive sign. There will be just 2 atoms and they will be attracted, right? There will be a force of attraction that is keeping them together. That is keeping them together. If I talk about ionic bond, so this is covalent and this is ionic. This is how they look. If you look in real life, this is the covalent, this is ionic. Now let us see what happens if I will have the extreme case. Okay, the extreme case. So what I'm doing, there is a positively charged lithium atom, and there is a big molecule, big ion here, that is iodine. So iodine will be having a negative charge, right? So this is lithium and this is iodine negative, lithium positive and iodine negative. So this is how I have represented them. Now, there will be electron density all around the iodine. There will be electron density all around the iodine atom. But one thing is for sure, this part of iodine, it will be attracted by the lithium. Yes or no, guys? It will be attracted by the lithium. Yes or no? Yes or no? The electron that is present in iodine, it will be attracted by the lithium positive sign, na? The positive charge of lithium, correct? Yes. Now, what is going to happen? And these electrons, which are which is outside the iodine, they are not very influenced by. There are protons in iodine also, even though it is negatively charged. It does not mean that proton has been decreased. No. Protons are there. The extra electron that the iodine has got, it is also attracted by the proton, but that attraction will not be very effective. Agree? Because of this distance, right, guys? The valence electron of iodine, they will be far away from the nucleus, and that is why this lithium positive sign will be able to, this lithium positive charge will be able to distort the electron, and it is going to form something like this. Okay, I am not able. Wait a second. Let me try it. So there will be distortion, right? There will be distortion of electron. Now, if I talk about the nuclei, this is the nuclei of lithium. This is the nuclei of iodine. And you can see there are electrons in between these two nuclei. Yes or no, guys? Correct? So there is some, now whenever you have this type of case where there is some distortion, and due to that distortion, there are electrons between those ions, there are electrons between those ions. So we are developing some covalent character. We are developing some covalent character inside a ionic bond. This is covalent character. Covalent character. So there are two things. There are two things. One is the cation, and the other is anion. So if cation is something that is distorting the anion, cation is something which is influencing the anion. The anion is getting influenced by the cation. The anion is getting what? It is getting influenced by the cation. So if the cation is of very small size, it can narrow the pull of electrons from the anion, and it can make some covalent character. It can make some covalent character. If I compare the pull of electron between two atoms, this is one of the case, and the other case is if you have positive and this is negative, both are of similar size. So you can see that these positive charges, they cannot narrow down the pull, right? They cannot narrow down the pull, and that is why this is not going to give you an effective covalent character. It is not going to give you an effective covalent character. So what do you need? So you have two conditions that you need to satisfy if you are going to find the covalent character in ionic compounds. First is cations should be of small size. Next is anion should be of large size. Now, when I look at the halides, cation are given by halides of group 1 elements. Cation are from the group 1 elements. So if I take the smallest cation, that is lithium positive, and the anions are from the halides, and if I take the largest anion, that is iodine negative, and then when we are forming halide of lithium and iodine, that is lithium iodide, it is expected, and it is true, that it is going to have covalent character. It is going to have covalent character. All of you, did you understand this concept of covalent character in ionic bonds? Yes or no? Tell me. Yes or no, guys?
Yes.
Khalil,
Yes, sir.
ma'am.
Yes, sir.
Okay. Okay. So these are the main points in your group 1 elements. Is there anything? Just wait a second. I think the compounds of important compounds, those have been removed, right? No? Yes. Nahi pata. Haan, guys? Anyone? No. The compounds, important compounds of group 1 and group 2, they are removed na, from the syllabus?
Yes, sir.
है ना? They have been removed. Okay. हाँ, मैमूना सही बताएंगी. Okay. Now there is one problem in NCERT that I want to discuss with you guys. Okay. I just hope they should not. I don't understand sometimes how NCERT works. For example, this question. There are many signs that you don't understand right now. I can see that. Here you have E negative sign something. Then you have Cl2 to Cl negative. Then you have some plus something. Then you have this notation I2 to I negative. Then there is plus something. Then you have Ag2 positive and sodium to sodium positive to sodium is something, right? And then lithium positive to lithium, it is. There are some things which are given to you, some data that is given to you. Okay. And they are saying that E naught. Okay. You don't know what is this, but you know that whenever you have anything like, for example, delta H, so this zero sign, it is pronounced as not. Okay, that is pronounced as not. So you have E naught for Cl2 Cl negative is plus 1.37. So I can say, okay, fine. They have given me some conditions. They are giving me some condition. For example, I should say elements. Maybe I can make a table of elements, and then I can say that it is E naught. They are giving me some combination. So they are saying that Cl2 Cl negative, and it is plus 1.36, plus 1.36. Then you have I2 and I negative, and this is plus 0.53. Okay, and then we have Ag positive to Ag. We have Ag positive to Ag, Ag positive and Ag, it is plus 0.79. We have sodium positive, sodium, this is minus 2.71. Then we have lithium, and lithium is given to be minus 3.04, minus 3.04. So let us understand what is this. Okay, we have never learned this. This is obviously not in the syllabus, these E naught terms right now. It is there in the electrochemistry chapter in 12th standard. Right. Then they are asking, arrange the following ionic species in decreasing order of reducing strength. Reducing, do we know? Yes or no, guys? We know reducing, right? Yes or no? What is reducing? What is oxidation reduction? Yes or no?
Yes, sir.
Anna, what is reduction? What is reduction is? Reduction is what?
Addition of hydrogen, removal.
Yes, but no.
So
Yes.
reduction of oxygen and addition of hydrogen.
Again, yes, but no. Yes, but no. Why? Reduction. Now, देखिए. There is one thing that I'm like telling you guys. Please, like, make this a rule of thumb. Make this a rule of thumb. It is something related to reaction. Yes or no?
Yes.
Now, whenever you are doing some reaction, you will try. I'm not saying that ऐसा होना ही होना है हमेशा, but you will try to boil it down to electrons. Yes or no? Because anything is reaction, that means it is something about the electrons. It will be either the gain of electron or the loss of electron. All of you, Muhammad, Khalil, Maimuna, Mehreen, Razan, you will try this. Yes or no?
Yes.
Okay. So
Yes,
what
sir.
is reduction? Reduction is addition of a gain of electrons. Gain of electrons. And what is oxidation? It is loss of electrons. देखिए, whatever you were saying now, we can also boil it down to oxidation, reduction, gain, and loss of electron. You said that reduction is what? It is either the loss of oxygen or it is the gain of hydrogen. Now we all know oxygen, whenever it will be attached to something, it is more electronegative. It is more electronegative, and it will be doing what? It will be coming with 2 negative charge, right? Yes or no? And if it is coming with 2 negative charge and it is getting attached to something with 2 negative charge, that means it is bringing some electrons, right? So what you are doing, if you are having oxygen and that is in somewhere here, like for example, hydrogen, oxygen, and hydrogen. So oxygen will be taking up electrons, right? Oxygen will be taking up electrons. Now, if the oxygen is taking up electrons, so let me show you guys like this. Okay, so if I talk about this hydrogen, what has happened? This hydrogen has done both the things. It has. I will come up with an example later on. अभी हम ये पढ़ा देते हैं आप लोगों को, है ना? Loss of electron and gain of electrons. Now, what is happening if I go from Cl2 to Cl negative? What is happening if I go from I2 to I2 negative? What is happening if I go from Ag positive to Ag, sodium positive to sodium, lithium positive to lithium? In all of them, I'm adding electrons. Yes or no? Cl is neutral, Cl negative, I added electron. I2 neutral, I added electron, I2 negative. Ag positive, I added electron, Ag neutral. Sodium positive, I added electron, sodium neutral. Lithium positive, I added electron, lithium. Yes or no, guys? Correct?
Yes, sir.
We are adding
Yes.
electrons. So in all of them, what is happening? We are reducing all of these. We are reducing all of these. There is reduction and there is oxidation. There are two more terms: reducing agent and there is oxidizing agent. Now, before reducing and oxidizing, we will learn about agent. All of you, those who live in Middle East, all of you must have heard about travel agent. Yes or no?
Yes, sir.
Yes, sir.
So travel agent travel करता है, travel करवाता है. What does the travel agent do?
Travel करवाता है.
करवाता है ना. He make other people travel. Yes or no?
Yes, sir.
Yes. So what will reducing agent do? It will get reduced or it will reduce others.
It will reduce others.
Yes. Others. Very good. It will reduce others. It will reduce others. It will reduce others. Oxidizing agent, it will oxidize others. It will oxidize other. Now, please tell me, if you are going to reduce something, if you are going to reduce something. So here we have A and here we have B. So what I am saying, A is reducing B. What is happening, guys? A is doing what? A is, अरे बोलिए अभी तो कहा हमने, can you please repeat that? A is reducing B. A is reducing B. Now, in terms of electrons, A is giving electrons to B. Yes or no?
Yes, sir.
Yes, sir.
All of you agree? A is reducing B. A is giving electrons to B. Now, if A is giving electrons to B, then what is going to happen? A positive, B negative. Yes or no?
Yes, sir.
Yes, sir.
What happened with A? This is our reducing agent. What happened to A? It got oxidized. Yes or no? Yes or no, guys? If I look at
Yes,
A
sir.
to
Yes,
A,
yes.
है ना? So reducing agent, how to identify reducing agent in a particular reaction? You, in the reactant side and in the product side, what do? You calculate the oxidation state. When you calculate the oxidation state, and if you see that there is an oxidation happening, that means that guy is the reducing agent. And what is happening with the B? B is eating electron of A. That means B is helping A to get oxidized, and hence it is oxidizing agent, and the oxidizing agent gets reduced. Okay, so there is something which help us to identify. This is the work of reducing agent. It will reduce other. That is the work. That is now how you will identify him. How you will identify the reducing agent and the oxidizing agent. Reducing agent gets oxidized and oxidizing agent gets reduced. Okay. Any problem, guys? Yes or no? Tell me.
No, sir.
No problem. Very good. No problem. So all of you understood till now what is reducing agent and what is oxidizing agent? Yes or
Yes,
no?
sir. Yes, sir.
Okay. Okay. Now you can say that this is E naught, and E naught, it is telling me something about the reducing power, because they are saying that Cl2 to Cl negative, it is 1.36, I2 to I2 negative is this much. है ना? So it is telling me something, because we can say that in all of these Cl2 to Cl negative, it is getting reduced, right? So we can say that all of these are reduction reaction, and E naught, it is giving me some idea about the reducing property, or the reducing strength, or reducing power. Reducing strength or reducing power. Okay. If I will talk about now, you guys, can you tell me which of the following has more reducing power? Hi guys. So it is, they are getting reduced now, है ना? They are getting reduced now. Reducing strength. How to see whether a particular reducing agent or an oxidizing agent is what? It is a good reducing agent or it is a bad reducing agent. If there is a good reducing agent, it will easily get oxidized. Yes or no?
Yes, sir. Yes.
All of you agree? If something is a good reducing agent and it can reduce other, that means it can get easily oxidized, right? So what I have to do, I have to rather tell the whatever this E naught is, but I have to tell about the oxidizing power. Okay, I have to tell about the oxidizing power. These are the reducing power. I have to tell about the oxidizing power. So what you will do, from reduction to oxidation, change the sign. Minus 1.36, minus 0.53, minus 0.79, plus 2.71, and plus 3.04. Okay, so these are the oxidizing power, and you can confidently see that lithium has the most oxidizing power, followed by sodium, and then followed by
iodine.
iodine, followed by what's next? Ag, right? And then at last Cl. Yes or no? At last we have Cl. Okay, so this is one of the questions that is very different from the syllabus that is there in 11th standard. So this is something that you will read before going to the examination. This part you have to read before going to the examination, because you may forget it and it is not related to anything that you have studied. This is most important part that you have to convert from. This is the reduction power given, and this is the oxidation power, and this is the oxidizing. This is the reduction power, like how a particular element is going to get reduced, and this is the oxidized, like the oxidation power, how fast a particular thing is going to get oxidized. And reducing agent is something that will reduce other and it gets oxidized. So the order will be sodium can oxidize most easily. Lithium, you have lithium also. So lithium followed by sodium followed by I negative followed by